Today we're going to be talking about 1-2. It's called Properties of Real Numbers. So if you look at the top of your notes here, N stands for natural, W stands for whole, Z is integers, Q is rational, I is irrational, R is real. Eventually we get to numbers that are not real, so it is important for you to think about them being real for now. So the natural numbers are also known as the counting numbers. So anything you can count on your fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Whole numbers are everything natural is plus a 0. So whole numbers are 0, 1, 2, 3, 4, 5, 6, 157, right? Integers are everything above it plus the negatives. So the negative natural numbers, if that makes sense. So the negatives, -3, -2, -1, 0, 1, 2, 3, dot, dot, dot on both sides because it goes on forever in both directions. Rational numbers can be expressed as m over n. M and n are integers where n cannot be 0 because then it would be undefined. So it's integers or fractions. Let's see here, terminating, repeating decimals. So for example, you could have, let's see here, would 0.125 be a rational number? Yes. Okay. What about 1/3, etc.? All right. So terminating and repeating decimals, what that means is this terminated, there's no dot, dot, dot at the end. This would be a repeating decimal, right? 0.3 repeating, or it's also already a fraction. So this goes with rational numbers. Irrational numbers means not rational numbers. So non-repeating, non-terminating decimals. Think of something that would be a non-repeating, non-terminating decimals. So for example, square root of 2. If you plug that in your calculator, that's not repeating, it's not terminating, it doesn't repeat, it doesn't stop. Pi is a common one that people think of, right? 3.14159 dot, dot, dot. That means it doesn't repeat, it doesn't stop. Okay? Another way to think of these is a non-perfect square. So square root of 2, square root of 3, square root of 4. No, square root of 4 is a perfect square, right? And then real numbers are all the rational and irrational numbers. So a number is either rational or irrational. It can't be both, so you have to pick one or the other. And if a number is natural, it's automatically whole, integer, rational. So I almost kind of like split above here separate from the irrational numbers. So if it's an n, it's automatically a WZQ. If it's a W, it's automatically a Z and a Q. If it's a Z, it's automatically a Q. It's not necessarily going backwards though, but this is always true. So let's go down a little bit here on the properties. For any real numbers a, b, and c, we have commutative property, we have associative property of addition and multiplication, you can tell here, identity, inverse, closure, and distributive. Okay? So commutative property of addition is where a plus b equals b plus a. So think of it this way. Does 2 plus 4 equal 4 plus 2? Yeah, right? 2 plus 4 is 6. 4 plus 2 is 6. They're saying CO, commutative property. I think change order. CO, change order. The order can change and the answer is still the same. Same thing with multiplication. 2 times 4, is that the same as 4 times 2? Sure, 8 is equal to 8, right? So the order can change with addition and multiplication and you get the same answer either way. That's called commutative property. Associative property is where you can move the parentheses around essentially. So here, a plus b plus c equals a plus b plus c. I know that looks the same, but it's not. If you follow order of operations with PEMDAS, you would have to do a plus b first here and then add the c. You would have to do b plus c first here and then add the a. But by the associative property of addition, they would end up being the same answer on both sides. Same thing for multiplication. A times b first and then times c is the same as b times c times a. These are all the same. If you were to plug numbers in, they're the same. This is a review of Algebra 1. This should be pretty easy for you. Identity property of addition, Identity property means you get that number back again. So what do you have to add to a number to get itself back again? So 4 plus what gives me 4 again? Well, 0, right? So 4 plus 0 is the same as 0 plus 4, right? And it gives me back the 4. So identity property of addition is where you add a 0. Identity property of multiplication, what do you have to multiply a number by to get that number back? Well, you multiply by a 1. So a times 1 gives me a back. Inverse, what do I have to add to a to end up with a 0? Well, I add the inverse of it, right? Negative a. What do I have to multiply by a to get a 1? I multiply a times 1 over a to get a 1. And then you have your closure property. A plus b is a real number. A times b is a real number. Distributive property, this is usually easy for people for some reason. A times b plus c in parentheses means a times b plus a times c. And then you can obviously move the parentheses, move everything around if you want to. Even if the a is in the back, it still ends up giving you the same thing. It's the same process. So now let's try these. If you need to pause or go back or write some notes, go ahead and do that. If you're ready, then let's go ahead and go on. Name the sets to which each number belongs. So they're asking what type of numbers are these. So if you go back up, we've got our natural, whole, integer, rational, irrational, and real. So you want to make sure you're looking up here when you answer those questions. I always start with natural. I just kind of go down the list. I ask myself, is it n? Yes or no? And then I keep going. So if we look at 62, is 62 a natural number? Let's start with natural. Is it a counting number? Not a decimal, not a fraction, right? Yes. So if it's n, it's automatically W, Z, Q, and R. It's all of them, automatically. We can think about it if you'd like to, right? Natural, yes. Well, whole is everything natural was plus 0. Integers is everything above it plus the negatives. Rational is everything above it plus fractions and decimals, essentially. And then real is everything we're going to talk about for a while. So it's all of them. Number 19, negative 8.13. Is negative 8.13 a natural number? No, right? No fractions, no decimals here. Is it whole? No. Is it an integer? No, you can't have fractions or decimals in integers. Is it rational? So here's our question. It's either rational or irrational, right? We have to pick one. If it's rational, it stops. Does this number stop? Terminate? Yes, right? If it had dot, dot, dot at the end, it wouldn't. But because there's no dot, dot, dot at the end, it stopped. So that automatically means it's rational. And again, for now, everything is real. So we have Q and we have R. 21 over 7. Whenever you do these problems, you want to reduce or simplify as much as possible first, and then you can decide what that number is. So I understand 21 over 7 looks like a fraction, but let's go ahead and say what it is before we determine whether it's natural, whole, or whatever. So what is 21 over 7? That's 3, right? So let's start with n. Is 3 natural? Yes, right? It's a counting number, so it's automatically what else? W, Z, Q, and all of them for now are real. If you're confused, pause, write some notes on the side, ask me a question. Let's go ahead and move on. Name the property illustrated by each equation. So we're back up at the properties part right here. Okay. So this says 6 times 8 times 5 equals 6 times 8 times 5. The first question I ask myself is, did the order change? 685, 685. No. So what is this not? This is not commutative because the order didn't change. What changed from the left side to the right side? Where the parentheses are located, right? The parentheses were around the 6 and the 8 here, and they're around the 8 and the 5 here. So if we go back up to our properties, the associative property, this is multiplication, obviously, so we're over here. Doesn't this look exactly like this example? The parentheses moved, but everything else stayed in the same position. So this is going to be the associative property of multiplication. All right, 27. 8 square root of 11 plus 5 square root of 11 equals 8 plus 5 in parentheses square root of 11. Let's go ahead and say what it isn't. Let's kind of just process of elimination here. Is this commutative property? It doesn't look like that to me, right? Is it associative? No, because we didn't have parentheses on both sides. It's not identity, it's not inverse. Closure, we don't usually even write down. So it's the distributive property if you think of it probably backwards is how you would think of it. So if you look here, if we distributed the 8 to the square root of 11, we'd get 8 squared of 11. If we distribute the 5 to the square root of 11, we get 5 squared of 11. So this is our distributive property. Find the additive and multiplicative inverses for each number. So we want the additive inverse and the multiplicative inverse. When you do your additive inverse, you want them to end up adding to 0. So all you really have to do is change the sign. For your additive inverse, you want it to add to 0. So just change the sign. So this would end up being negative 12.1. For your multiplicative inverse, you want it to multiply to a 1. So all you're going to have to do there is just flip the fraction. So this is really the same as 12.1 over 1. That's weird. A decimal and a fraction is weird. We'll get to that later in the year. For right now, we're going to go ahead and flip it to 1 over 12.1. Well, that's still, again, that's weird. For right now, that's okay. If we change 12.1 to a fraction, it's 12 and 1/10, right? Let's make that an improper fraction. You multiply, right? 12 times 10 plus the 1 ends up giving you 121 over 10. So let's just flip that fraction. That's probably easier than what we just did. Flip this fraction and you get 10 over 121. If we were to multiply these two numbers together, we get a 1, which is our goal. You go ahead and try 33. Find the additive inverse of 6 over 13 and the multiplicative inverse of 6 over 13. So again, to find the additive inverse of a number, you essentially just change the sign. So this is a positive 6 over 13, so we want negative 6 over 13, right? To do the multiplicative inverse, you flip your fraction. You want them to multiply to 1. If I multiply this by 13 over 6, I get a 1. Simplify each expression. Whenever it says simplify, that's an important vocab term. You need to make sure you understand what that means. It does not say solve. If it says solve, that means x equals 4 or something. If it says simplify, you're probably still going to have letters in your answer, and that's okay. So you just combine like terms as much as possible. You still follow PEMDAS, right? PEMDAS, P-E-M-D-A-S. Even though this stands for parentheses, it's really grouping symbols. So you do grouping symbols, then exponents, then multiplication, division, left to right, then addition, subtraction, left to right. So if possible, can I combine anything in here? No, G and a K are not like terms, can't add those together. G and a K are not like terms, can't add those together. So my only option is to go ahead and do multiplication. So we're going to distribute this negative 2 to everything in here, and the negative 9 to everything in there. If you think you know how to do this problem, go ahead and pause, get an answer, see if you got the same as me. Negative 2 times negative 5g is positive 10g. Negative 2 times positive 6k is negative 12k. Once you do the multiplication, the parentheses go away. Don't write those anymore, you'll get confused. Be careful to remember this negative sign. Negative 9 times negative 2g is positive 18g. Negative 9 times positive 4k is negative 36k. Now that we have that done, we can add and subtract common terms. So the g's would be able to be added together. 10g and 18g is 28g. And then the k's, negative 12k and negative 36k, is how many k's? Negative 48k. Is there anything else we can do? Can we combine the G and the K? No. It said simplify, we followed the directions, we're done. Why don't you pause, try this one yourself, follow the order of operations, see if there's anything you can do to get this problem correct. Okay, so on this problem, we're going to do the same thing. We're going to distribute the 2/5 and we're going to distribute the 3/4. You're welcome to use a calculator anytime. That doesn't bother me at all. However, let's try not to until we absolutely have to. You can multiply 2 over 5 by 6. That's really easy to do, right? 2 over 5 times 6 over 1. You multiply the numerators, you multiply the denominators. So that's going to be 12 over 5c minus 2/5 times 8d is going to be 16/5 d. This is going to be a plus sign. 3/4 times 4 over 1, the 4's cancel, and it's just going to be a 3c. And this is going to be a minus sign. The 4 and the 9 don't cancel this time, so 3/4 times negative 9d is negative 27/4 d. So here's where I would be okay if you used a calculator. This isn't a big deal. Most of these aren't like terms, or excuse me, aren't common denominators, so we don't need to take time finding common denominators. You have a calculator, let's use it. So the c's are going to be able to be combined. 12/5 plus 3. If you use your calculator, you're going to get 5 and 2/5 c, or you're going to get 27 over 5. It's all the same. It doesn't matter. As long as you reduce it, I don't care if it's a mixed fraction or an improper one, which is 27 over 5. So negative 16/5 d and negative 27/4 d. If you use your calculator, most of you have an ABC button. It looks like this. So if you want negative 16 over 5, you would punch the negative 16, this button, and then the 5. And then you would subtract 27 over 4. You should get, again, depending on your calculator, negative 9 and 19 over 20, d. If you don't know how to change that to an improper fraction, you can let me know in class and I can show you what buttons to push. It's actually really easy. So here's where you're going to pause the video. You're going to write down some notes if you have questions on the side. You're going to come in, ask me questions, let me know how I can help you.